We're going to have a look at Minilab 1.2.1 in this clip. This is a pretty straightforward lab. It just requires that you have access to a wheel and a tape measure, and you understand some terminology. And the terminology is typically where we run into some problems, being able to identify specific aspects of the wheel here. So let's look at question number 1. This is the text of the report, and this is just a picture of a cross-section of a wheel. So record the wheel diameter. We want to be clear that the wheel diameter is where the tire sits. So if I look at this wheel cross-section, the edge of the tire is going to sit in these areas I've highlighted in red. That is the wheel diameter. I do not want this measurement here. So if I measure from edge to edge on the wheel, it's typically going to be around an inch larger in diameter than the wheel's actual diameter. Okay, so we want to make sure we're measuring from the correct places, or taking that into account anyways. Record the wheel width. So we have a similar issue there. If I measured from here to here, I might think that's the wheel width. It is not. The wheel width is, again, where the tire sits. So I'd measure between these 2 points here. That would give me the wheel width. Record the pilot bore diameter. This is where we start to get some different terms used. So here we're calling it a pilot bore. You see in this picture it's called a center bore. What this is the hole in the center of the wheel. So what size hub will this fit over, basically? So we just measure the diameter of the opening in the center of the wheel. Record the bolt circle. So bolt circle's a bit interesting. Bolt circle is a fairly obvious thing. If I have an 8 or a 10 bolt wheel, I can see that all those bolt holes are arranged on a circle. If I have a 3 bolt wheel, it looks like they're arranged on a triangle. They're not actually on a triangle. It's just with so few holes, those are the points you see. So the diameter of the circle, if we use the 8 bolt wheel as an example, the diameter of the circle is from center to center, from holes opposite each other across the wheel. If you get odd numbers of bolt holes, like 3 or 5, the measurement has to be done a little bit differently. If you look at the theory module 1.2.1, it'll tell you how to do that. Does this wheel have, or sorry, we're the backspacing. So record backspacing. So backspacing is from, so this will be the mounting surface here. That's where the wheel will mount up against the hub of the vehicle. So I want to measure from that to the back edge of the wheel, and that will give me my back spacing. So it just tells me how far the mounting surface is from the back edge of the wheel. Does this wheel have a positive or negative offset? Now this has to do with whether the mounting surface of the wheel is at the center line of the wheel. You'll see center line is identified right here, or I've got this marker right here. So that's the center line. You'll see that the mounting surface is slightly inboard of that. So that has a negative offset. Not much of one, but a negative offset. The rule is if this mounting surface is inboard of the center line, it's negative, and if it's outboard of the center line, it's positive. Okay, does this wheel have any safety ridges? Here they're labeled as safety humps. Again, it's just a minor terminology thing. These are designed to help retain the wheel. They're really helpful when you're first installing the tire. When you're first installing the tire, you'll find it kind of pops over that. And you have to remember those things are in place because when you go to take a tire off of a wheel, you have to break the bead and push the tire over those humps as well. Most wheels have them both inboard and outboard. Some wheels only have them on the outboard, and many wheels have a small one on the inboard side and a large one on the outboard side. Regardless, have a look, see if you can identify them. Now, what material is this wheel made from? Virtually every wheel you're going to run into is going to be made out of steel or aluminum. With a little bit of practice, you can easily identify what material you're dealing with. There are other wheel materials out there, like some hyper exotic wheels might be made out of carbon fiber, but you typically are not going to see them. Now, other materials might be magnesium, which is similar to aluminum, a little bit lighter, and materials like that. we want to know what we're looking at because they tend to have some different problems. Again, if we go back to what you usually see steel and aluminum, steel wheels, if they get hit, bang, they can get a little bend in them, and sometimes it means nothing. It might be just cosmetic damage. And they're fairly durable and can be repainted and put back in service if they're scuffed up badly. Aluminum wheels, they behave a little bit differently. They tend to be more susceptible to corrosion damage, which can lead to problems getting the wheel to mount properly on a vehicle, or it can give you air leaks from around the tire valve or from where the tire seats on the rim. So you just want to pay more attention to corrosion, particularly on aluminum wheels. Okay, number 9, inspect the following areas of the wheel for corrosion, cracking, etc., etc. And identify as good or no good. Tire seating area, so that's in here where the tire is going to contact the wheel. Is it in good shape? This is an area where it's common to find corrosion that may need to be addressed if you're putting new tires on there. The wheel rim flange, that's the very outboard edge of the wheel here. It's inboard flange, there's an outboard flange. That's just a little bit of a lip that hangs over the side of the wheel. That area is susceptible to damage from curb strikes and things like that. So have a look, make sure that that's straight and intact. Particularly on aluminum wheels, if they get struck there, sometimes they crack. So the wheel would need to be replaced. Again, steel is a little more forgiving. It tends to bend more than crack. The wheel mounting surface, so where it bolts on the vehicle, again, aluminum wheels in particular, inspect for corrosion. You want to make sure that the wheel is going to bolt up securely. The bolt holes can suffer from damage from going on and off multiple times, or from being incorrectly tightened or run loose. If the bolt holes are damaged, the wheel needs to be replaced. There's typically not a lot you can do with that. Okay, visible bends or distortion. So just look overall at the wheel and see if it's in good shape. Now here, is the wheel suitable for service? Yes or no? To clarify this, when I ask if something is suitable for service, I'm saying, is it capable of being put into service on a car? I'm not asking you if it requires service. Okay, so if the wheel is in good shape, yes, it can be put into service. If it's not, if it's got some damage that needs to be addressed or it needs to be replaced, then no, it can't be put into service. And as a service technician, when you be expected to perform a wheel inspection? Well, it's not the kind of thing that you do on a regular basis. It's not like you get a car in every 6 months to do a wheel inspection, but you still need to pay attention to some of these details. So if you're doing a tire rotation on a car, you want to make sure that the bolt holes and mounting surfaces are in good shape, so that when you do the rotation, you don't have a wheel come loose after you've worked on the car. If you're changing tires, you want to look at the whole wheel, make sure it's not going to leak, it's not going to cause any kind of grief. You want to do the repair on the car, install the new tires, whatever, and have it be a permanent repair. So you would definitely inspect the wheel under those conditions. Okay, that's it. I hope that clarifies things a bit for you, and you can go ahead and perform the lab.